Welcome back. This session is on Virtual Laboratory Pneumatic VLab by Dr. S.D. Agashe and Mrs. Meera Khandekar. The brief about the Dr. Agashe. Sir is from College of Engineering, Pune. Sir has done PhD in Instrumentation and Control and graduated from COEP in 1989. Having the experience of 23 years, out of that 7 years industrial. Sir is the member of IEEE, life member of Instrument Society of India, life member of IST. Academic and research attainments are, Sir is actively involved in developing industry supported laboratories at COEP, developed evaluation framework for the laboratory work, virtual laboratory project since 2009, developed and patented a flow meter with solenoid actuation, actively involved in implementation of Industry 4.0 in industries, development of smart energy meter, remotely operated laboratories for students from other institutes where the facilities are not available. Then Sir has published a number of papers at national and international level. Current projects are laboratory project, mission education through ICT, MHRD sponsored NME ICT project, virtual laboratory and remote triggered laboratory. Consultant for Pimpri Chinchwad Municipal Corporation for water treatment plant SCADA project. So Sir's more involvement in the development of laboratories and then the real hands-on expertise. Since it is a blend of the industrial and then the educational expertise. Along with him, Mrs. Khandekar, I'll be happy to introduce her as well. She is assistant professor of instrumentation and control at COEP, having 15 years of experience and around 15 papers presented at national and international level. Ma'am is also a member of IEEE, ISOI, FPTS, and organized and participated in various programs and workshops. So this program, this session is there on the virtual labs, and we know that how important is this in these days of pandemic. In pandemics, the students cannot come to labs where this virtual lab helps a lot, and we will take a flavor of it. So I invite sir and ma'am to give us the insight of it. So over to Agashe sir.
Hi, good evening, ladies and gentlemen. My talk is basically on latest trends in teaching and learning. And as you all know, evening sessions are always difficult and even difficult for a teacher also. And that's the reason I will try my level best to keep you engaged in a laboratory which we developed and which has become very, very essential as far as this pandemic is concerned. This entire project is supported by Government of India under National Mission on Education through Information and Communication Technology. Before I start saying something, I like this statement of Einstein where he says the only source of knowledge is experience. And how do we get the experience? And that's the million-dollar question in front of all of us. And that's where the challenges under the laboratory is very, very important, though it is pre-COVID or maybe during COVID. And these are the challenges I'm sure all my faculty members are facing and industries are criticizing. The first and foremost is we have limited contact hours with students. After 6 o'clock, there are very few laboratories in the country associated with academic institutions which are open. Reduced weightage for laboratories in the curriculum because there is some amount of financial obligation also in running the labs and maintaining the labs. And that's the reason many of the labs become outdated, or I call them as in-shelf technologies. And what do I mean by in-shelf technologies is these are the laboratories which are basically related to what is called as demonstration. The other point is there are ineffective and traditional teaching and learning processes which we are observing, And it pinches me as a teacher also to talk about it, but there is a solution to that. And the last point, which is very, very important, and I congratulate and thank the organizers of Fluid Power Society of India to call us to deliver a session in this conference. It's lack of awareness about industry exposure and happenings. So it becomes more theoretical part of it when we talk about and when we teach in the class. If you go to the during COVID, there are a lot of problems students have faced, and the education sector is most affected sector as far as this COVID is concerned. And the first and foremost is we are closed for last almost 1.5 years. We are almost closed, looking at the safety of the students. We and the government have taken a decision not to start the academic institutions. So the access to the laboratories have become more complicated. And as you all know, laboratories are backbone of engineering education, and we are away from that. My students are suffering. But when we start giving them access to the laboratories through projects like virtual laboratories and remote triggered laboratories, we came out with another limitation. And that limitation is related to the bandwidth. As we all know, students are from every corner of the state, or in certain cases, even from India. There are issues about the bandwidth, there are issues about the electricity, and that's what is the challenge. There is a lack of awareness about unsupervised learning. What is important in Indian education system very specifically is eye-to-eye contact, talking to students, taking them in confidence, being in the class, supervised mode of a learning. But now it has become unsupervised learning. Students are not ready to handle this situation. At the same time, I'm sorry to say, but my faculty members are also not trained for unsupervised learning. And that's where the contact between a teacher and student is not there. Though we say that we form the groups, we have so many access parameters, we keep on talking to the students, none is really effective unless and until we are in the campus. And that is the fundamental reason why certain things are required, why technology is required, so as to ensure that there is no break in the education system. I understand whenever there is a break in the industrial sector, there's a lot of hue and cry, but the same thing is true as far as the education systems are concerned. That's where we took a survey and we understood what's happening actually. Just to give you an idea, taking a clue from project work, each and every student of engineering goes through a project work, and the total number of students completing engineering education in the country is about 1.1 million, dropped from 1.5 million to 1.1 million. Now, if we consider our related branches like mechanical production, instrumentation, in industry sector, there are 0.5 million, 500,000 students are in those branches. They are putting in their last year around 185 hours of project work. So if you compare that, we all put around 92.5 million hours of work for project in the country. And if you look at the outcome of the entire thing, it's really not praiseworthy. Like according to many surveys, and this is also as a teacher, it pinches me, some survey says that 80% of our students are not up to the mark. You can't recruit them directly. You need training, you need retraining. It really pinches. And we all, I'm sure all my faculty colleagues sitting here attending, listening to this program, we all are taking every effort to make sure and ensure that there is a little gap between theory and practice. But finally, 30% students are jobless. That's another fact of life which we need to understand, and we need to change the entire curriculum. We need to change the way we are thinking. And that's why we have talked about two solution approaches, because let us not forget, laboratories will give you a lot of things, exposure for basic concepts which you have learned through theory, but reconciliation of that theory would happen only in the laboratories. And there are two types of labs which we developed. And interestingly, these are not the labs which are developed because of this pandemic. We were not even knowing about it when this project started. This project started in the year 2009 when Government of India announced that we need to reform the education sector drastically. And that's where government started putting money in education sector, understanding what technologies will be useful for that. And a typical laboratory, when you say that you are physically there, your instruments are connected, you are performing the practicals. Whenever you are performing those practicals, if I train you before, because after 6 o'clock, my students are not under my control. Before around 10 o'clock, my students are not under my control. So out of 24 hours, 8 hours are only under the teacher's control. 16 hours, students are on their own. We keep on giving them assignments, but the learning which happens won't happen so nicely. And that's where we said, can we take out some of their time by giving them tools and the resources where students can be hooked up to. Anyway, they have their mobiles. So can we hook them up? And that was the idea which started in 2009. And today we have developed more than 1,200 experiments, and still 900 experiments are yet to come. We all are working on that. And that's a typical thing which is happening here. Now, the question here is, if I train on a virtual platform, and then if I ask a student to come and perform the practical, the performance of a student in the lab improves. And that's the study which we have already published in an international conference. And that was a study with the students, those who were using virtual laboratories. So there is definitely meaning for the virtual laboratory to take place and use those virtual laboratories. Now, if you look at the what we are looking at is focus towards learning by doing, not only learning, being in the classroom, develop learners' professional skill, because when you are into a mode of unsupervised learning, you have to develop those professional traits which are really required, the timeliness, the communication, teamwork, all those things would come into picture. And that's what we have understood. And it has been witnessed by many students that there is a development in the professionals, and encourage a learner to apply their theoretical knowledge to engineering solution. So all our experiments are basically problem statement oriented experiments. Very interestingly, who are the participants of this is basically you will have number of remote users. The students and the professors can be anywhere. They can access the labs which are hosted on the cloud, the virtual laboratories cloud. Thankfully, Government of India under this project is also developing Indian cloud. And that's what is going on. But who are the partners? 8 IITs, premier IITs, starting with IIT Delhi. IIT Delhi is the main partner in this project. And then 8 IITs, 2 universities, one IIIT Hyderabad, NIT Surathkal is part of it, and the only engineering college from the country which is taking part in this prestigious project, a novel project, is College of Engineering, Pune. I am associated with this project since 2009, and it has now become an emotional attachment with this project. And that's what we have started working on that. What I'll be doing is after this, Meera would be presenting her lab, which is related to the theme of this conference, the get together of your community, our community. It's Pneumatic Systems Lab. She will be demonstrating that lab. And after that, I will join again and I will demonstrate you a remote triggered lab. The idea of a remote triggered lab is sitting anywhere. You can operate the plants, pilot plants, which are situated in College of Engineering, Pune. And that's what is the message which I wish to give you to all industries also, to how to collaborate. And that's what I'll be talking about it after some time. Now I will hand it over to Meera. She will explain you the pneumatic lab. And this is the analysis. More than 3.6 million students have already used these labs, and many page views are there. And these are the labs which we are using. Over to Meera, please.
Yes, sir. Thank you, Agashe, sir. We at Department of Instrumentation and Control, we have developed virtual labs for sensor modeling. We have developed virtual lab for programmable logic controller, for industrial automation, for process loop components, and for pneumatic system. Today, I am here to demonstrate you virtual lab for pneumatic system. Let us understand what is pneumatic system. Pneumatic systems are widely used in engineering industries like food and beverage, pharmaceutical industries, automobile industries, etc. We are using pneumatic systems for different engineering applications like pick and place the product embossing, product sorting. For these kind of engineering applications, we have been using pneumatic systems. So let us see what pneumatic system, how pneumatic system works. So basically, there are different types of components. So for beginners, it's very difficult to understand how to select the components, how to use the component. What do you mean by double acting cylinder? What do you mean by single acting cylinder? What are the different types of actuations and direction control valve? So here you can see this pictures for different types of valves. So looking at the picture, it's very difficult to understand what type of actuation mean is used, what type of direction control valve it is. Where is the exhaust port? Where is the pressure port? Where is the working port? So it's very, while operating the pneumatic system, it's very important to know how that particular component we operate. So these are the symbols. For beginners, one should know the meaning of the symbols. So what do you mean by 2x2 way valve? What do you mean by actuation port? What do you mean by spring return valve? What do you mean by manual actuation? What do you mean by 3x2 way valve? What do you mean by normally closed valve? So as per ISO standard, symbols are available. So to operate a pneumatic system, direction control valve play a very important role, and we as a learner must know the operation of direction control valve. Learner must understand the symbols as per ISO standards. So here we can see the list of symbols as per ISO standards, and before designing the pneumatic system, student must understand what are the ports, what do you mean by 5x2 way valve, what do you mean by 3x2 way valve. So this understanding is very important while before designing the pneumatic system. There are special control valves for pneumatic systems like flow control valve, pressure valves, sequence valve, relief exhaust valve, shuttle valve. So many pneumatic component symbols are available, and learner must have understanding about these symbols and where to use those symbols. So if user has to operate the single acting cylinder, so which components user required to select, how to connect the components, learner must to understand these things. How to design pneumatic solution. As I told you, we can use pneumatic system for different engineering applications like sorting the object, product embossing. So to design pneumatic solution for these kind of applications, so which are the components required to operate the cylinder, how to connect the component to operate the cylinder. So this understanding learner must have. So for 21st century education, expected learning outcome is to design a real life solution for engineering problem. So it is expected to change the learning and teaching methods. So it is required to learn the things by doing. So instead of referring the textbook for learning the pneumatic component operation, student has to operate the component and has to learn how that component operation take place. So it is very important to develop professional skills. So student must know the symbols as per the ISO standards. Student must know the parts and positions for the components. So with this aim, we have developed the pneumatic system virtual lab. So here is a link available for user. User can access the lab from anywhere at any time. So as we have discussed, there are so many things before designing the pneumatic solutions learner has to learn. So here is the scope of laboratory. So pneumatic components laboratory is developed as per the ISO standards. Pneumatic direction control valves, flow control valve, pressure control valve, delay valves are available. Then learner has to implement a pneumatic circuit in the simulator. Simulator will guide the learner if learner goes wrong. Then learner can simulate the pneumatic circuit. So here just you can go through the. So this is how we have developed the pneumatic lab. And this is how we can actually operate the setup. So now what we will do, we will operate the demo. So to log in to the virtual portal, we have to use credential, sign in to the VLab portal. So here we have to select the pneumatic system laboratory. Learner can see list of experiment developed for pneumatic system laboratory. So objective is develop pneumatic circuit for direct control of double acting cylinder. So objectives are mentioned for each experiment. Learner has to go through theory so that to understand the type of components and symbols as per ISO standards. So student will understand what are the actuation means and what symbols have been used for different types of valves. Learner will refer the theory for using simulator. So detailed theory has been given to use simulator, how to use simulator. So user has to click on the simulator. Here learner will select the operation. Operation is to design pneumatic circuit for direct control of double acting cylinder. So user has to think what are the components required to operate double acting cylinder. So learner will select the required component. What is the actuation mean? Actuation method will be manually actuated. So when selected components are right, then we can go to next level. Here we can see the list of pneumatic component as per ISO standards. We have to select the pneumatic component as per the requirement. Learner has to identify the component as per the standard. Here learner will see where is the pneumatic port P, where are the working ports A and B, which are the actuation means, and where are the exhaust port. As I told you, here we are going to use manual actuation method. So user has to select that actuation. Otherwise, while identification of the symbol, user guide simulator will pop up the message wrong selection of the component. After symbol identification and identification is successful, please next step is we have to do connection. After checking connection, we have to go to next level. learner have to go to next level. We can actuate the so learner can observe the extension of the piston. Learner will observe the airflow direction and change in the valve position. So after deactivation of the switch, piston will retract. So how airflow take place, how valve position, DCV position change. So it's very easy to understand after this simulation. So after simulation, learner has to complete the post test and he has to submit the post test. So these are the references used for the to design the experiment. Thank you. I will request Professor Agashe to demonstrate remote triggered lab. Thank you.
Hi, thank you so much, Meera, for this wonderful simulation of a pneumatic system. Now, what I'm going to do is I'm going to show you the remote triggered laboratories. Now, what do we mean by remote triggered laboratories? Why we are calling them as remote triggered laboratories? Let me share with you. The idea is whenever you have a plant and you wish to operate the plant remotely, we call that as a remotely triggered plant. Now, in this pandemic, most of the industries have their own problems. So can technology help them? Engineering institutions which are using these remote triggered laboratories of College of Engineering Pune has got immensely benefited because of these laboratories. What is this lab all about? The lab is we have the control system like PLCs or function block diagrams using standard symbols, and students would be given a chance or book a slot, and the access of that entire plant would be given to that particular student. The beauty of this is a student needs to understand first what that pilot plant is all about, the theory behind that, understand and develop the logic using virtual laboratories first. Now, this is very, very important, and we call that as a hybrid mode of learning. What is that hybrid mode? Whenever a student is using the virtual laboratory, physical plant is not connected to that. So he can practice, he can fail, nothing will go wrong. That's the beauty of virtual laboratories. Now, once he has practiced and once he has got the confidence and a certain amount of maturity, then we ask him by conducting a test that now you can book a slot and ask for the experiment. We have 13 pilot plants like the boiler and heat exchanger, evaporator, dryer, and even the plant like where we have used pneumatic systems like dispatching a conveying system, dispatching the bottles, placing those bottles, filling those bottles. All these experiments are part of pilot plants. So like you can see here, the control system diagram where a student has developed a logic. Now the question here is, once he has developed the logic, what is important for him is the dearth of failure. Can I fail? If I do something wrong, what will happen? That is where we give them full confidence that even if you wish, I will repeat my statement, even if you wish, you cannot damage my system. So enough care as far as safety is concerned or the malpractice is concerned is already being taken care of by the developer of these labs. And that's the reason a student can learn even through failing. He will develop some logic, it will work, it may not work. Now, just to go to, I'll just show you the mimic of the boiler and heat exchanger plant, which is a live mimic, which is available to a student. So the screen which I'm showing you is a screen of a student. So the student, he or she will find out that there is the temperature of the boiler drum, how much is the level in the boiler, how much is the pressure, how much is the SCR fired. All these things are known to him, and these are all dynamic displays. So whenever you change a setting there. Whenever you start converting and using those boilers, fire the boiler and start the boiler, you will find things will happen. For example, if you can see here, at present that heater is switched off, and he has developed some logic to switch on the heater because the task given to that student is to raise the temperature of water so as to become it as a steam, and I want to use that steam in heat exchange. Can you do that? Can you fire a boiler? Now that's the experience what a student will get. And all these boilers and all these pilot plants which we have, these are all industrial grade pilot plants. These are not tabletop models. So all the dynamics associated with the plant is now known to student. So there is nothing called as instantaneous generation of steam. It will take some time. So he will realize that simulation may happen quickly, but actual plant may not happen. So that delay would be shown to. Now what I will do is I'll start the heater because I want to start the boiler. So what I can do is I will give a toggling switch to the heater, and then I'll give a command that the heater should start with 100% value, right? So, and I'll submit that. So once I submit, the command would come through my server to actual my PLC, and then you will find that now that button has become green. That means the boiler has started. Now student has to confirm that yes, this temperature is increasing or not. If the temperature is increasing, that means I have given a command which is correct, interlocks are all right, and then the temperature slowly will increase and the boiler will start functioning. Now, whenever a student is performing this experiment, this is very, very important for all of us to know that in all these experiments, whatever a student is doing, everything is being captured and being shared with the student. Now you can see here the temperature is increasing slowly. It will take some time, but the temperature is increasing. That means the command which he has given or the student has given has reached to the system. Control system has started. The heater has started, not only converting or changing the LED from red to green, but physically something is happening. Now when he does that, the student will do this experiment. What will happen is at the background, every 500 millisecond, we are capturing all the readings associated with this experiment. So we are generating an Excel sheet. Now what is important here is to know that whenever we are performing any experiment in the laboratory, what happens normally is maybe because of the time constraint, because of the laziness of students, and so many other reasons, a 2 hours experiment normally gets covered and over by 45 to 1 hour, and that's it. And a student can take 4 or 5 readings only. So whenever you are performing this experiment, you will get thousands of readings, and that too automatically. That means the laborious part of the experiment is reduced and the intelligent part of the experiment is being enhanced. And that's the beauty of remote triggered laboratory. Now what I'm going to show you is, as the temperature is increasing, I'm going to show you how a valve is being operated. A control valve is being operated, and that control valve I'm going to show you through a camera. Now, if you can see here, there is a camera available, right? So there is a default location, and this access of that camera is given to a student. Now what I'm going to do is I'm going to now give a command to that control valve, a pneumatically operated control valve, that you operate 100%, right? Okay, so the command is given, and if I go to a control valve, just see the control valve is moving, the stem of a control valve is moving. A student who has an understanding that how control valve works, actually sitting in a college where facilities are not there, why the quality of engineering is less, or maybe sometimes my industry colleagues are saying that below normal, and the reason is exposure. Please believe me, we have to give exposure to our students about the system, how things are moving. So the camera control is also with the student. This is a PTZ camera, IP camera. So the control is given to a student, and the student is operating a plant. Now he gains the confidence that yes, I can sitting here, I can operate the plant. And that's the beauty of the entire system. Now, whenever I say that that's the beauty of an entire system, the mimic, can you go to mimic? So if you go to mimic, you will find that yes, now there are certain things have happened. The temperature has gone from 27 to 48, the wall is open, and naturally what will happen, the pressure will start building, and this is an actual plant a student is handling. Now this is very, very important aspect of this thing. And what happens whenever we are collaborating with educational institutions through nodal centers, we call them as nodal centers. Many of the colleges across the country are the nodal centers of this virtual laboratory. Now what happens actually is the performance of a student in the form of which experiment he has performed, how many mistakes he did, what is, I have asked him to control temperature up to 100 degrees Celsius, whether he crossed the limit, and if he has crossed the limit, why. All this analytics, all this data is being captured at the background in a subtle way, because one of the aspect of this virtual laboratory, remote triggered laboratory, is no policing. We don't want policing. Actually, students should have that maturity, saying that I want to have my own career in my career in front of me. Why should I bluff the system? So I will perform the experiment seriously because I want that. And that's the message which we want to give. But in a subtle way, we share this information to the faculty members, indicating that these are the areas where student is lacking. So can you take care of that theoretical portion or the background of a student, maybe a theory background of that student, so that a bunch of students will get benefited because of this. The message which I wish to give, because I was talking to Professor Khod and Professor Avinash, and I was very happy to note even in COEP also there is a lab from Eton. The laboratories are being sponsored by the industries. Now, whenever you are sponsoring those laboratories, my request to all of you is, can we have a collaborative platform around the lab? Instead of duplicating the laboratories, can we say that, okay, COEP will have these distinct pneumatic and hydraulic components. Some other college will have another different component, so that utilization of students from other colleges can improve. We can convert your labs into remotely triggered labs, and the students from other colleges also will get benefited, so that the students with the facilities available with them physically can visit those laboratories and perform the practicals, and the students, those who are at the remote location, can still perform the practicals, but through these technologies which we have developed. College of Engineering Pune is of course ready to share all the technologies which we have developed, the evaluation platform which we have developed, and because it's a project of Government of India. Can we go to presentation? Yes. Yeah. So in that, whenever we are talking about the remote triggered laboratories, what is important is we have also having a skill-based postgraduate diploma in industrial automation in Department of Instrumentation and Control. Now, these are my colleagues who have developed those laboratories. Meera is of course part of that, but these are the team of developers, a very dedicated team of developers, those who have developed these laboratories and made it a point that it will be used by the students. I must acknowledge Ministry of Education, because under this National Mission on Education through ICT, for last 11 years we are working, and I'm very happy to share with you all these 8 IITs and 2 universities, IIIT, NIT Surathkal and COEP, all principal investigators have continued working for this project. Our idea is to make sure that 80% of students are not eligible to join, change that scenario. 30% are jobless, change that scenario. Because for a teacher, it is always pinching that somebody who is going out of the campus without any meaning, without any job, without anything to do, or without any chance to use his or her knowledge which he has gained in an educational institution. I'm sure industry partners will also support us, develop the laboratories, set up those laboratories, but now change that mode, set up the remote triggered laboratories by just investing a camera and the platform which we have developed, so that the students from other colleges across the country also will be benefited, and we all can say that our engineers are worthy joining the companies next day, participating in the project next day. Thank you so much for uh, giving us an opportunity to participate in this. And if you have any specific question, me and Meera would be ready to answer these questions. Thank you so much.
Just lab is very useful to engineering education. Since I am also teaching this subject, and if we do it on trainer, then it is a costlier a business. But when we do it, sure.
Dr. Avinash, I have sought your permission to interact with Professor Agashe and team
Yes,
on this subject. Can I?
Yes, sir.
Yeah. Dr. Agashe, first of all, I must place on record my deep appreciation for the work what you are doing along with Professor Meera Khandekar. In fact, I was to ask you a question, which
Yes,
you have in your own statements answered it, that what can we do for you for this virtual lab? And the way I understood is that you would like to extend the experiments to a very fruitful and productive end by collaborating with other engineering colleges, splitting the whole project into parts and people at different places doing it sequentially, right? It's an excellent suggestion. Now, the way you have taken this project from Ministry of Education, it will be appreciated that on similar lines, if you be the coordinator and give a total program of your virtual lab, where you will need the help or other resources in terms of manpower from other engineering colleges, in terms of some financial support from the industry, so that you can complete that. That is one. I beg to put my comments on a few things, like virtual lab is not going to be the total solution of hand-on experiences. What we learn by seeing it, by hearing it, and by doing it, there is a difference of 30%, 60%, and 90%. So doing it as hands-on experience, not virtually, but actual hands-on, will also be needed. So perhaps it's going to be a combination of more of virtual lab where students have understood the experiment, but still getting on to some hands-on experience in the laboratory, because if they don't understand how to hand spanners and the hammers, you ask for a ring spanner and say, where is the ring? Can you give me your ring from your finger and I'll bring the spanner from there? It shouldn't happen like that.
Yeah.
Okay, so that also is very essential. So once again, appreciating what you have done. This was only a sort of suggestion of mine through the comments, that in case you make a total proposal, it will be highly appreciated. And we at FPSI, in case we need to interface in convincing the industry to extend their support, by all means, it will be our pleasure. Thank you.
Thank you so much. Thank you so much. I just want to repeat one statement. Virtual labs is not the substitute for actual labs.
Right.
Yeah.
Right.
Appreciate. Thank you so much. Thank you.
Sir, there are a number of questions. Those are in now chat box. The first question is that can we not simulate the processes used in the lab rather than actually doing experiments physically? Shall I repeat it?
No, I understood the question. We can simulate the processes or the plants and then convert them into virtual simulator. That's absolutely all right. That is possible. But the only thing is there are certain physical processes, there are certain delays, there are certain dynamics which is there in actual system. Your simulator may not be perfect. That's the only difference. If you're ready to accept that, no issue on that.
Now the next question is by Chaitanya Kulkarni. How you can guess the maintenance time in that automation project? How you can guess the maintenance time in that automation project?
Yeah, let me answer this, because what we have done, we have to make sure that the plants are up and running all the time. We have used some statistical tools to ensure that how much is the wear and tear of that equipment, how the instrument is deviating. Now I'm talking in terms of instruments only. I'm sorry, because I'm an instrumentation and control engineer. I'm not a mechanical engineer. So the maintenance required for mechanical components, I'm not really aware about. But as far as instruments are concerned, we are keeping a track of statistical record of all the data, and we calculate how much is the uncertainty which is there and how much is the deviation for a standard reading. That's how we test.
Yes, sir.
Yeah.
Next question is also by the Chaitanya Kulkarni. How you can guess the maintenance time in that automation project? Yeah, how you can guess the same there.
Same.
Yes, sir. Actually, here also I would like to comment that the how you, so we can, it is an approximate solution, isn't it, sir? And we can reach to the practical solution. So how to make it complicated, that is in our hand. So making it simple is the right solution. So nicely presented this. One more question I received now. The one more question is that is the virtual lab being under government of India is only accessible in India only or outside India too?
See, these labs are, Professor, these labs are hosted on the cloud, and there is no restriction as far as the usage is concerned. So anybody sitting anywhere, even we have hits from other countries also, right? So anybody can use these laboratories from anywhere. That's the answer.
Yeah, that's the beauty of virtual lab.
Yes.
That's the beauty of virtual lab, and we go on developing it, and there is a contribution from your side in the pneumatics. It's a really appreciable work, since we are also in this field and for many years, but we are coupling with the components and then with trainer.
Yes,
so with
sir.
this,
Thank you, sir. Thank you very much for giving us opportunity to demonstrate our labs on this FPCA platform. Thank you very much, sir.